David Smith here with another Flipped Classroom math video. A few tips before we start. Remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or try the problems before I explain them. Lastly, you could turn on the captions and read my words going along below the bottom of the screen. Today's topic is the first lesson in our exponential functions chapter. So what we're going to do is experiment with exponential functions, learn a bunch of laws. We're going to end up getting into logarithms, which is a pretty cool topic. Basically, exponential functions are functions where the variables are in the exponent. So up until now, we've been doing quadratic functions, where the variable is the base, and then the power is some number, like x squared or z to the sixth power. Those are quadratic functions. Exponential functions have variables in the exponents. So here's an example. F of x, remember this is our function notation, f of x equals 2 to the x. So 2 to the 2, 2 to the 3, 2 to the 4. This is called the doubling function because each time you increase the x, you're going to double the last result again and again and again. So let's say x is 4. 2 to the 4 is 2, times 2 is 4, times 2 again is 8, times 2 again is 16. So that's an exponential function. I want to talk a little bit about domain and range and how that works with a function. So the input, this is the independent variable in science. This is the number that you pick. So with this function, you're free to pick whatever you want for x. So that's the input. That's called the domain. And the way I remember that is that my domain is something I'm in control of. I get to choose the value. So the domain is the input. That's our x. Here's our function. The function is just like a box. You throw x in it. The function behaves according to set rules, and it spits out its output, which is y, and we call that the range. Now the way I remember range is out there. It's on the range. It's not near me. I can't control it. It's out there. So that's kind of my explanation for how to understand domain and range. Okay, so let's talk about domain and range of this particular function of 2 to the x. So the domain, these are the numbers that I get to pick for x in this function. Now, what it's asking us is, are there limitations? Or can we put any number we want? And in this case, we can. We can put negative numbers, we can put 0, we can put positive numbers, we can even put fractions in for x, and it's going to be fine. Typically, limitations on domain revolve around getting division by 0. And there's really nothing we can do there that's going to create a division by 0, which we can't do in mathematics. So the domain for 2 to the x is just all real numbers. Okay, so that's how you evaluate the domain. Now the range, we don't control the range. The range is produced by the function once we pick a value from the domain. So let's take a look at kind of what we'll get out of this. That'll give us a feel for range. Let's try something interesting. Let's try x is 0. So 2 to the 0, that's 1. We're good with that. Let's try something else. Let's try 2 to the 4th power. We did that a minute ago. That's just 2 times 2 times 2 times 2, which is 16. So I probably don't need to test bigger and bigger numbers. It's just going to double that many more times. So it looks like we can get, the domain can just keep growing, growing, growing. So let's try some smaller things, or maybe some negatives. Let's try 2 to the 1/2 power. Okay, now what's the 1/2 power? That's the square root of 2, which is approximately 1.4 something, something, something. So that works. Let's try something else. Let's try a negative number. We did 1, now we did 1/2. Let's try 2 to the negative 2. Now if you remember your exponent rules, the way that works is this becomes 1 over 2 to the 2, which is 1/4. Okay, so I can pick negatives. Let's see what happens if I go bigger with negatives. Let's try 2 to the -4. That's going to be 1 over 2 to the 4, which is 1/16. Okay, so here's the tricky question. What happens as we keep getting more and more negative with our exponent? That fraction, the bottom number of this fraction is going to get bigger and bigger and bigger and bigger. So that number is going to approach 0. Right? Think if we did 2 to the minus 1 million. That's 1 over 2 to the millionth power, which is a ginormous number. We've doubled 1,000,000 times. That's a super, super, super big number. But 1 over a super big number is actually really small, but it's still positive. Okay? So the range for this function is all real numbers greater than 0. You'll never get 0 out of this function. So it's all reals greater than 0. Now I think I did that backwards. All reals, yeah, greater than 0. There we go. So that would be the range for this function for 2 to the x power. Now you'll get some exercise questions that will ask you about domain and range for functions. This is a good starter. If you have questions, obviously bring them to class. Okay, so let's do some basic calculations with a very straightforward exponential function. So now I've got g of x. Remember, you can use any letter. We had f of x in the last one. Now we're doing g of x. This is some form of the doubling function. It's not straight doubling because now we have a little algebra going on in our exponent. So whatever we pick for x, we're going to subtract 4 from it to figure out what our result is. So I've written down 4 problems there. If you want to pause the video and see if you can work these, do that. Otherwise, we'll just go through them. So what's g of 0? G of 0 is going to be 2 to the 0 minus 4, which is 2 to the negative 4, which is 1 over 2 to the 4, which is 1 over 16. So that's what g of 0 would be for this function. Okay? So try g of 5. It's going to be 2 to the 5 minus 4, which is 2 to the 1, which is just 2. Okay? So I think you're probably getting a hang of how these exponential functions work. Let's try g of negative 2. That's going to be 2 to the minus 2 minus 4, which is 2 to the minus 6, which is 1 over 2 to the 6. Now you can pull out your calculator, but the doubling function is pretty easy. 2, 4, 8, 16, 32, 64. So that's 1/64. How about g of 7? That's going to be 2 to the 7 minus 4, which is 2 to the 3, which is 8. Okay? So that's a basic, although slightly more complicated exponential function, and we're just finding our values. Okay? Okay, now let's do a different function. This time we're calling it h of x, and this is going to be 6 plus 5 to the negative x power. Okay? So let's do some plugins. H of 2. We're going to do 6 plus 5. Now we change the sign. So that's going to be to the minus 2. That's going to end up being 6 plus 1 over 5 to the 2, which is 6 and 1/25. Okay? That's what we get for h of 2 for this particular function. Now let's try the next one. By the way, pause the video, give this a shot. See if you can get it. This will be 6 plus 5 to the minus 2. So that's going to be 5 to the 2. 5 to the 2 is 25 plus 6 gives us 31. Okay? Now try this last one. See what you get. Okay. 6 plus 5 to the negative 0 is the same as 5 to the 0. Negative 0 doesn't have a meaning. So what's 5 to the 0? That's 1. So this is 7. Okay, one last example. J of x is 3 minus 2 to the negative x. So let's do these. Please pause the video and see if you can work these through yourself. You definitely have enough from the last 2 examples to pull these off. Okay, let's see how you did. When j is 0, we have 3 minus 2 to the negative 0, which doesn't really have any meaning. We could just write 0. That's the same difference. What's 2 to the 0? That's 1. Anything to the 0 power is 1. So 3 minus 1 is 2. That's what we get for that one. Let's try j of 3. That's going to be 3 minus 2 to the minus 3. Right? I've got a negative in front of my variable there, so that's my plug-in step for that. So this would be 3 minus, now what's 2 to the negative 3? It's 1 over 2 to the third. 2 to the third is 8, so this is minus 1/8, which makes it 2 7/8. Okay? Last one. Notice how I'm plugging in a variable. So I'm not going to get a number answer for this one, because I'm not starting with a number. So let's try that. 3 minus 2. Now I've got negative x there, and I have negative x there. So that's going to cancel, and I'm just going to have 2 to the x. And that's as far as I can get with that one. Now that you've finished watching the video, take a moment to jot down any questions you have so you can bring them to our next class and get some help. You can also watch the video again to perfect your understanding. If you enjoyed it, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.